Hey students, I'm recording from my classroom today. For period 5, I won't be here, so this is your introductory lecture to the ideal gas law. For the rest of you, this is a good resource that I hope is helpful to you. So, we are learning all sorts of stuff about pressure and temperature, and we did these simulations and we learned this conceptual stuff about how, like, if you heat up the temperature, the particles go faster, and that means they're going to hit the wall harder, so that means higher pressure. Well, how much, right? If possible, in science, we like to quantitate things. We want to know, if I double the temperature, exactly how much is that going to make the pressure go up, right? Well, it turns out that over many years of research and many scientists contributing, this thing was discovered called the ideal gas law. Okay, so the ideal gas law is an equation that allows us to calculate these things, like that can answer the question like I said. So here's the ideal gas law. It's P times V equals N times R times T. That's capital P and V, capital R and T, and lowercase n. It should all be that way. What does all this mean? Well, P is pressure, okay, and so you take the pressure times the volume. And we've discovered that if you do that, it will always equal the number of moles of gas times this R, which is a constant, 8.314, and then you multiply that by the temperature. And if you measure these things about a gas, then both sides of this equation will always end up being equal. Now, not every gas in real life behaves ideally, but most gases do, right? Common gases like helium, oxygen, etc. Okay, you can use the ideal gas law to make calculations about these gases. And this is one of the state standards. This is used a lot in meteorology. Meteorologists have to use weather balloons, and they use this equation to do calculations about how much helium to put in the balloon. Anything dealing with compressed gas, this is the equation you need to use to deal with that sorts of stuff. And also hydraulics in machinery, right? There's a lot of applications to the ideal gas law, and that's why the state of Minnesota put it in the standards. It's a really useful thing, okay? So, a couple things about units. Pressure, the international unit of pressure is the kilopascal, okay? Just to give you an idea of what a kilopascal is, okay, normal air pressure is 101.3 kilopascals. Honestly, I have no idea where kilopascals came from or what that unit is based off of, why air pressure is 101.3. It's kind of a weird number, but there it is. So about 100 kilopascals is the normal pressure that you experience in life. Anything higher than that is higher pressure, and anything lower is, obviously lower. Liters, number of moles. We're back to moles again. They never go away. This is how we measure how much gas, because you can't weigh a gas on a scale, right? So number of moles will give you an idea of how many gas particles there are, right? R. This is just, it's a constant. It's called the ideal gas constant. It's 8.314. That number never changes. So get this into your notes because you're going to need that number again. And then the temperature has to be in kelvins. So the reason I talked about units here is that to use this equation, all the units have to be like we look at here. You got to have kilopascals, liters, kelvins. Okay, let's try an example. We got an example I just made up here. A kid has a balloon outside. It's a 1 liter balloon, which is about the size of an Nalgene bottle. The temperature outside is 298 Kelvin. That's a normal room temperature. And the pressure outside is 101.3, right? The normal atmospheric pressure. So this is a helium balloon, and we want to know, well, how much helium is in that balloon? If you have a volume of 1 liter, how many moles of helium end up in that balloon? Well, step 1 to solving any equation is to write down the equation. So every time you do a problem, I want you to write this down, PV equals nRT, okay? And then the next thing we're going to do is you got to have lanes, right? Like I'm going to plug in a number for P. What is the pressure? Well, that's up here. It says right there the pressure is 101.3. So I'm going to write down this number, 101.3, times V, Okay, and I'm going to put V in parentheses because that's one way to show multiplication. V is the volume again, 1 liter. Okay, equals N. N is number of moles. Remember up above, that's number of moles. And this question is asking how many moles. So that's our unknown. N is the one that we don't know. So that's just going to stay N, because I don't know what that is yet. That's what I got to solve for. R, we just set up here, R is 8.314. Okay, so N times 8.314, that's R. And then finally T is the temperature. And the problem tells us the temperature right here, 298 Kelvin. So 298. Okay, so you see how I very carefully went through every item in this equation, and I wrote something down on line 2 here. Here was my line 1, here's my line 2. I wrote something down for each one of those items in that equation, and you should too every time. Well, now we have to solve this, right? What we want to arrive at, right, is what does N equal? This is my goal at the end, is to figure out what is N. Well, I don't know if you remember this with the diluting equation that we did, but whenever you have an unknown like this, all you got to do is divide by the number next to the unknown. Okay, and that's going to give you your answer. Now, I have 2 numbers next to my unknown, and they're supposed to be multiplied by each other, so I'm going to do that multiplication first. Okay, so let's do this first. 101.3 times 1, that's just going to be 101.3. N stays the same, and then I'm going to grab my calculator, and I'm going to take 8.314 times 298. Sorry, hitting myself in the face here. 8.314 times 298 is 2477.572. This number here has 4 digits in it. You see that? Oops, sorry about that. So I'm just going to keep 4 digits in this one. 2477.5, that rounds up. So 2478. And now I'm sitting at a spot where I have 1 number sitting next to N. That's good. And whenever you're multiplying some N by some number, you want to get rid of that, you do the opposite, which is divide. So remember this, that we divided both sides by the number that's next to the N. We're doing that again here. The reason we do that is now we have 2478 on the top and the bottom, so that cancels. And after those cancel, I'm going to be left with N equals something. And that's exactly what I want. So I grab my calculator and I punch up that last bit. 101.3 divided by 2,478 equals 0.04087. That's a lot of numbers. Again, I'm just going to keep 4 digits, so 0.0409. I'm rounding up right there. 0.0409. And N is the number of moles, so my units here are moles of helium. And we're done. Okay, that's it. People in the math and the science world, the further you go, we call this plug and chug. We plugged in the numbers right here. And then the chug part is solving. Plug and chug. That's all this is every time. Okay. Let's do one more, because sometimes they're a little more complicated, right? Down here I've given you a problem where I gave you 25 moles. That's N. But I didn't give you the temperature in kelvins. I gave it to you in Celsius. And I didn't give you the volume in liters. I gave it to you in milliliters. How are you going to deal with that? Well, write these down in your notes. If you want to convert from mils to liters, there are 1,000 milliliters in a liter, so you got to divide by 1,000. To convert from Celsius to kelvins, you add 273.15. And that's it. So let's do this. N. Oh, actually, remember I said my first step was write it out. PV equals nRT. Okay. P. I don't know. that's my question. That's my unknown. It says, what's the pressure? Right there. Okay, so I just copy down P. V is the volume. Should I write down 1,500? No, I should not. Okay. What I need to do is divide by 1,000. Okay, V is that. Pop it into your calculator. 1,500. Some of you know this in your head already. I can tell. I can hear you saying it. That's 1.5 liters. Good. Now I have V. That's 1.5. I did P. I did V. There's the equals. N. Already in moles. I'm happy about that. I don't have to convert that one. R. Always stays the same. 8.314. Don't have to do anything with that. T. Celsius, not Kelvin. Uh-oh, we got to convert. Let's go over to the scratch paper. T equals 27. And it said to convert, we're going to add 273.15. So here we go. Plus 273.15 equals 300.15. You can use your calculator if you want, of course. You go right ahead. There's my temperature, okay? Got to make sure that that's in kelvins. Got to make sure that volume is in liters. Hey, I'm pretty much back to where I started before, right? I'm going to do a little simplifying here because here's 3 numbers in a row that could be multiplied. Let's go ahead and do that. P still times 1.5. There's nothing I can do with that. And then we will multiply out these 3 numbers. 25 times 8.314 times 300.15. We're going to get a big number here, aren't we? 62,386. All right. Yep, sticking with that. Now what do I do? Did my liters, did my number of moles, did R. Yep, this is all looking good. Remember, when I have this simplified down to where I am, divide both sides by the number next to our unknown. I'm trying to get P alone. So if I divide both sides by 1.5, then that's going to cancel the 1.5s. And now P is going to be alone. P equals, that's exactly what I'm trying to figure out. Grab my trusty calculator. I still got that number in there, so I can just hit divided by 1.5. 41,591. I had to round up because of the 0.7. Kilopascals. So what do you think? Is this a high pressure propane tank or low pressure? Right? Well, normal atmospheric pressure is about 100 kilopascals, and this is 41,000. Whew! There is some high pressure in that tank, and that's exactly how it is in real propane tanks, right? They are steel pill-shaped things for a reason, so that they can hold all that pressure in. That's some serious pressure. I hope that this makes sense to you. I have an assignment posted that will help you practice these skills. Really, this is it, what I just showed you, okay? You plug in the numbers, solve for the unknown. Sometimes you got to do a little bit of converting on the side, but that's it, okay? Nothing more to learn about this. Make sure you got this in your notes, and happy calculating. See you later.